Hello everyone, welcome to my YouTube channel. Today we are starting engineering mechanics. This is the first chapter of that is introduction. So I'm following the textbook of R.S. Gurmi. There is a multicolor edition of this textbook that is very attractive. If you haven't bought any book for engineering mechanics, do buy this. That is a very good textbook. Okay. So if you haven't subscribed to my channel yet, please do subscribe and press the bell notification. So let's get started. So, engineering mechanics. What is engineering mechanics? Engineering mechanics means that we are using the principles of mechanics in order to solve engineering problems. So, let's read the definition. Engineering mechanics is that branch of applied science which deals with laws and principles of mechanics along with their application to engineering problems. So it deals with the law and principles of mechanics. Okay, so engineering mechanics is further divided into statics and dynamics. As the name suggests, static means that the body is static or at rest. So what will be dynamics? The body is in motion. So let's read the definition of statics. It deals with the forces and their effect while acting upon the bodies at rest. Dynamic means it deals with the forces and their effects while acting upon the bodies in motion. Dynamics is further divided into kinetics and kinematics. So, dynamics means that the body is in motion. So, kinetics deals with the motion and the forces which are causing the motion. And kinematics, only motion is regarded here. M stands for motion. Only motion is regarded here. The force which is causing this motion is not given any reference. So let's read the definition for kinetics and kinematics. Kinetics deals with the bodies in motion due to application of force. So the motion and force both are considered here. And kinematics, it deals with the bodies in motion without any reference to the force which are responsible for the motion. So acceleration and various trajectory of the particle is considered here, but not the force which is causing the motion. Then there is two definitions, that is fundamental units and derived units. Fundamental units, as the name tells, these are fundamental units like M, L, and T, where M is mass, L is length, and T is time. In SI unit, we represent mass in kilogram, length in meter, time in second. So these are the fundamental units. And derived units means from the fundamental units we derive these units. So example is area, velocity, etc. So if it is a square, then area will be L square or meter square. Then velocity means meter by second or L by T. So from the fundamental unit L and T, we derive unit for velocity. And from the fundamental unit L, we derive unit for area. Such definition, that is derived units. Okay, such units are called derived units. Then scalar quantities. Scalar quantities means like length and mass, like 3 meter, 5 kg and all. There is a magnitude for this, but there is no direction. Such quantities are called scalar quantities. These are those quantities which have magnitude only. Example is length, mass, time, etc. Then vector quantities. Vector quantities means they are having both magnitude and direction. Like suppose 5 kilonewton load is acting downward or 5 kg load is acting downward. Then there is a direction force for that force. Then 3 kilonewton is acting eastwards. Like that. There is a direction in which the force is acting. So example of this is force, displacement, velocity, etc. So vector can be unit vector, equal vector, like vectors, etc. Unit vector means, as the name suggests, the magnitude will be unity. Equal vector means that the vector will be equal. See, vector, it will have a magnitude and direction. We into some scale we draw the vector. See, if suppose this is a line drawn to represent the vector magnitude, and the direction is represented by an arrow. We draw this to some scale, like 1 centimeter is equal to 3 kilonewton, like that to some scale we draw this. So that this dimension, this distance will represent the magnitude of the vector, and the arrow mark will represent the direction of the vector. So this will be the representation of vector quantity. So equal vector means that the vector will be having same direction and same magnitude. That is like this. this vector will be having same magnitude and same direction. It will be parallel to each other. That is what it means by equal vector. Then like vector means that it will be having same direction. That it is like. These are friends. Okay. So these are like vectors. This will have same direction, but it may be of different magnitude. Like a tall boy and small boy are friends, like that. It will be having different magnitude, but they have same direction. They are parallel to each other. That is like vectors. So there will be addition and subtraction for this vector. So suppose PQ and RS are two vectors. So we have to add these vectors. So in order to add the vector PQ and RS, we are drawing AB that is parallel to PQ to some scale. So we draw AB. Then RS, starting from B, we draw RS that is parallel to the initial RS. We are drawing a vector BC, which is parallel to RS and to some scale of RS. So like this we have drawn it now. And the diagonal or the closing line of this will represent the resultant or addition of the vector PQ and RS. So AC here represent the magnitude and direction of the resultant vector or addition of this AB and BC or PQ and RS vectors. So that is addition of vectors. This is triangular law of vector addition because this is a triangle. Okay, triangular law of vector addition. So suppose if it's a polygon, so then what will happen? There will be many things like P, Q, R, S, A, B, C, D, like that. There will be many vectors. So we have to add all these vectors. Then what will we do? First, we similar to this triangular law, we add first two vectors. Then with the resultant, we add the other vector. That is this one and this one now. So then we'll get a new resultant. So with the new resultant, we add the other vector. That continues till the total vectors are added. That law is called polygon law of vector addition. Polygon law of vector addition. So we can add as many vectors as possible using this law. So this is the simplest case, that is triangular law of vector addition. Similarly, we can subtract vector also. PQ and RS represent two vectors having a magnitude and direction as shown in this figure. So similar to this PQ, we draw an AB to some scale that is parallel to PQ. Then similar to RS, we draw a line which is having magnitude to some scale of RS and direction similar to RS. So like that we draw, starting from B, we draw a vector. So closing this two, there will be a vector that will represent the subtraction of this vector. That is AC represent the subtraction of PQ and RS. So that's done. This is the addition and subtraction of vector. So if you like this video, please do share and subscribe my channel. Thank you for watching my video. See, in this lecture series, I won't include any question papers in the description box. So for the whole engineering mechanics topic, after the video series, I will have a video especially on the previous year question papers and other important questions. So we don't expect any question papers in the description box. Okay.